Okay. Welcome to this GSG. This week I have you down as working on sections 1.6 to like 1.10. Is that about right? Is the kind of material? Okay, awesome.
Yep, that's where we're at.
Awesome. Do you guys have any particular questions about this? There's a question that Kasha asked me to go over from the quiz, so we can start off by doing that, and then we can kind of take your questions as they come, or just do some practice problems from the sections. That sounds all right?
Sounds good to me.
Awesome. Okay. So, give me a sec. I am going to get that question from the quiz. Okay. This should look familiar to you guys. Would anybody like to tell me where to start for this problem? Like, how do I start solving this problem?
Can't you find at P0 what the constant is? After.
Yeah, okay. So the goal is to find what the constant is. Oops, that's not what I meant to do. Come on. Meant to draw. Okay. The goal is to find this constant K. And we're given this information if the population is 1/4 the initial population. So, and we're given a time. So the way that I like to set things up, you'll see as like we continue on in the semester that one thing that I do a lot is write everything down so I can keep track of it all. I'll just say like right off the bat that I know that t equals 5. We're given p0 as just like a constant, and we know that p is equal to what? It's 1/4 p0. And then we're just going to put all of this into the equation. So we have 1/4 p0 is equal to p0 e to the negative k t, where t is equal to 5. And then we just put this through and solve it. Process-wise, thoughts on this? Exponential growth and decay can be kind of problematic, I think, especially like conceptually. But especially, I think the toughest part for some people is like accepting that this is like a viable option for P. Do you guys have thoughts on this? Is there something specifically that is tripping you guys up, or? Okay, Casey. What? Okay, we're talking about this problem here that was on the quiz. Yeah. Okay. So I think like we can talk about this a little bit later, but I think there might be some in my last semester there were a lot of people who didn't like the fact that we could do and like put this as a valid P. But we can, especially because these P naughts are going to cancel out. Okay. So I think perhaps we should have started in 1.6 and then built up to this. Are there any specific questions about how this problem is solved?
Well, can we finish solving? Because it's not done, right? Because don't you have to
yeah.
get the logarithm on top? And
yeah, from here on it's like pretty much just like you've done the setup of the problem. It's just the algebra now. You'll divide each side by p naught. So you'll end up with 1 over 4 is equal to e to the negative 5k. My calculator is in my backpack right now. So if somebody has a calculator, I'd appreciate it if you pulled that out to do this. But you take the natural log of both sides.
Which would cancel out that e.
Yes. To bring that down. And we know that this is equal to 1. So divided by negative 5k is equal to the natural log of 1/4 over negative 5. And this is just, especially because I don't think you guys will have calculators on your exams, this is a fine form to leave it in. But you can like do the full calculation and get like a 0 point ... like whatever number it is. So like, how do you guys feel, I guess, like on a scale of 1 to 10, just like put it in the chat box or say it out loud. How do you guys feel about the material that you covered this week? Like 1 being, I have no idea what's going on, and 10 being like, yes, I get this. Like, I totally know. Okay. We gotta vote for 4. We gotta vote for 7. We have an 8. Okay. So some people seem to get it like fairly well, but at the same time, there's people with a lot of reservations, and I totally get that about this material. Why don't we start going over problems from the book? Does everybody have their books with them?
Yeah, I got mine.
Okay, awesome. Okay. So let's start in section 1.6. It's where we start talking about logarithms. Okay. How do you guys all feel about logarithms?
I was working on it a lot yesterday, but I guess I could definitely use a refresher. Seems every morning.
Yeah, because like I think like just conceptually, like people can understand like different types of functions like in different levels, and I think logarithms are just like something that people have a lot harder time with. But the most important thing to like look at and see is that the natural logarithm of what's ever in here, is just a function. So there's just you put an x in here and you input and you get an output of y. And the natural logarithm is something that just does like a change to that x to make a y. It's just a function, an input output. Same, like we could write it as f of x. So input the x and then we output the function. So natural logarithms like enact some sort of change on a function. And just like that, when we're doing algebra with them, like to solve a problem, we have to do it to both sides. Okay, let's start with problem 6. So problem 6 looks like this. Okay. So this is the kind of problem that we would need a logarithm to solve. We usually use the natural log because it's just kind of like the easiest generic one to use, but you can technically use whatever logarithm you want. And then because we're treating this as like a function that we enact, we have to do it on both sides. For instance, if we were to like multiply both sides by 5 or something, we would have to do it to both sides if we were trying to like solve this problem, or if that would be useful, or divide it by 5. In this case, it's not useful, but we have to remember that just like we would do that with like dividing and multiplying, we also have to do that with logarithms. So we have to take the natural log of both sides. So we end up with natural log of 100 is equal to the natural log of 25 times 1.5 to the t. Can anyone tell me what we do next?
We divide out that 25, correct?
That is not the first thing I would have done.
That's kind of how I get to the answer.
Okay. I usually don't mess with stuff when it's like inside the logarithms, because I guess like, I don't know, like when it comes to dealing with logs, I just would separate this out first and get everything in terms of the logarithm, because this is like a multiplication inside. I would make this the natural log of 25 plus the natural log of 1.5 to the t.
So is the way I'm doing it going to get me in trouble? Because I divide out the 25 before I even add in the natural log.
Oh, if you were to do that, then you'd be fine. Yeah.
Okay.
If you were to divide by 25 up here,
Yes, that's where I'm doing it.
then you're A-okay and you'll be fine.
Okay, thank you.
But once it is inside the natural log, you have to separate it out like this. So let's do 2 lines of thought. Here we'll have 4, and here we'll solve it like the way that I did, which admittedly now is more complicated and unnecessary. But so this is still the natural log of 100. We'd subtract the natural log of 25. And we'd use our rule for subtraction to say that this is actually 100 over 25. And then this would just become the natural log of 4. And then this t, we would do what with? Where does this t go? Because it's an exponent, yep, and we're taking a log, it goes out front. So it's t natural log of 1.5. That being said, up here, we would just take the natural log of 4, natural log of 1.5, and the t ends up out front when we're taking the natural log. So we end up in the same place both ways. Your way is probably smarter because there's less opportunity for you to make mistakes with computing logarithms in here. That being said, where do we go after this? We're just going to isolate the t and call it good. So the answer is going to be t equals the natural log of 4 over the natural log of 1.5. Can I simplify this? Yes, no, maybe so? Yes, on a calculator, I could definitely simplify this into just a string of numbers. Can I simplify this in terms of natural logs? The answer is no. I cannot use that rule where you have the natural log of like a over b is equal to the natural log of a minus the natural log of b. And the reason I can't do that is because this is the natural log of something that is being divided, and this is a number over a number. So it might look like you could just make this into some sort of subtraction, but you can't. And because of that, just like keep that in mind, because sometimes they'll do that to trip you up on like quizzes and exams. Okay. Thoughts on this problem? Scale of 1 to 10, easy, tough, 10.
That one's pretty easy.
Yeah, you guys are rocking this then. Okay. Cool. What about problem 18? All right. Problem 18. We are identifying initial quantities, growth rate, and stating if the growth rate is continuous. Okay. What is my initial quantity?
7.7.
Yep. And the reason it is 7.7 is?
It's kind of your y-intercept where the initial quantity is. Not a good explanation.
I would use a different explanation. I'm trying to think if that's true, if it is the y-intercept. Yeah, it would be. What I would call is the initial is when t equals 0. And anything to the 0 is 1, so this is 1. So initial, yep, when t is at 0. Initial is just this times 1. And that's how I think about it, at least. And there'll be a lot of different like initial value type problems later on, so I would just kind of remember this initial is when t equals 0 and kind of like integrate that in how you think about problems. Okay, so we have our initial value. Is this growth or is this decay?
Growth, because it's not a negative.
Okay.
For the constant is a negative.
Okay. We have 1 vote for growth, and then we also have a vote for decay in the chat box. The chat box is correct, Casey. This is our A value right here, and this is less than 1. So what does this mean? The way that I think about it is like, and I still do this. I look at that and I say, what happens when t gets really, really big? If t were to equal 100, what would happen to this number here? And the answer is it would get really small, because as you keep multiplying 0.92 times 0.92, it just gets smaller and smaller and smaller. So this is going to be a decay, because then if I multiply that by 7.7, it's going to get smaller still. So okay. All right, then, sorry, I'm getting like a reverberation from somebody's mic of my own voice. Is anyone else getting that?
Yeah, I think it might be somebody's TV or somebody who called in, possibly.
Okay. Okay. Sorry, guys. Okay, we're good now. Okay, so then if we have identified that it's decay and we've identified the initial value, the remaining question in this problem is, what is the growth rate, or in this case, the decay rate, and is it continuous? Thoughts?
I would say it's definitely a decay, as we already discussed. Looks continuous. It's decaying at 0.08, which I guess would be 8%.
Yep. if this A value here was 1, then it just would never change. Because it is 0.92, we're losing 0.08 or 8% every time t increases. We're losing like more. Yep, from 100%. So if you consider this to like, if you just relate this to like percentages, that's how I start to think about these kind of problems. Okay. I think we're done with 18. Why don't we give 20, let's do 42. Wait. Are you guys comfortable switching from between the two forms? Like, you know how this is done?
No, that's probably one of my biggest problems right there is switching.
Oh, okay. Well, let's do that. Then we're going to do 26. Let's do P is equal to 10.1, 10 times, excuse me, 1.7 to the t. Okay. Again, like it really just kind of matters how you think about things. And in what terms. I know that P is also equal to P naught E to the KT, so I'm going to put that right here. Because I know that it's equal to both of these things, and I know that both of these equations are valid. I can then just think about this. If I divide both sides by P naught, I get A to the T is equal to E to the KT. And then what I do is I say that these are virtually the same. The difference is this K up here. And what actually is true is that A is equal to E to the K. So really, both of these equations are exactly the same. The only difference is that one is in terms of E and one is not. And both have their own merits for their own reasons. But would you like me to solve this whole thing out? It's just ln A t. Yep. T k ln E. That's 0 divided by t. Ln of A is equal to k. And then you take it to the E again. So A is equal to E to the K.
I think the first way you did it just helped me out a ton.
So, yeah. The point is that this is true. And you can use this to convert between the two forms. That being said, this is in the form A to the T. I don't know why I wrote A. Actually, I do. I should not talk and write that. Okay, give me a sec. See if my eraser will do its thing. Maybe. Come on, Zoom. Okay, here we go. Okay, so because this is in the form A to the T, and we need to get it in E to the KT, we know that A is equal to E to the K, and we know that A is equal to 1.7, and we know that E is just a number. Are you guys comfortable with the fact that E is just like 2 point yada 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 yada?
Yeah.
Okay. It's just like pi, it's just a number. So we have everything we need to find what k is. So we'll take the natural log, k natural log of e is equal to natural log 1.7. This is 1, so k is equal to the natural log of 1.7. And again, because you often don't use calculators on your exams, I'm just going to leave it in this form. This is a totally fine form for an answer to be in. And that is what your k is going to equal. So when you put it back in, you have p is equal to, this is still our p naught right there. So we have 10 e to the natural log of 1.7 times t. And this is equivalent to 10. And that's how you convert between the two of them. You relate a and e to the k. I think we can get some practice on that with problem. Oh no, we wouldn't get practice in this problem. I'm not entirely sure which problems are on you guys' homework, so I'm kind of hoping I don't do any of those. Or I guess you guys already turned in your homework for the week? Maybe?
I don't think we turn in actual homework. They have homework problems, and we work on mostly odd problems. So we have the answer in the book, so you're probably safe with even problems.
Sounds good. All right, thank you.
You're welcome.
Do you guys want to try 28 then? Like, just give this a try on your own and reconvene in a couple of minutes and talk about what you guys got as an answer?
Sounds good.
Okay.
Can we put that screen back, because I was working off of that, the previous screen?
All right, how we all doing?
I'm ready.
All right. Anyone in the chat box want to put their answer in? If it's easier in the chat box, you can just put in what you found k to be. And can I erase this?
Yeah.
Cool. All right. All right. Paul in the chat, yep. Or we're looking good. K we found is going to equal the natural log of 0.55, which would mean our whole thing ends up looking like P is equal to 4, which is our P naught, our initial value, times e to the natural log of 0.55 times t. Okay. In terms of growth and decay, is this growth or is this decay?
It's decay because it's less than 1.
Yes. Is everybody comfortable with looking at this and seeing that it is decay? Because one of the easy ways that you found to do that is to check and see if this is negative, and this is in fact negative. All right. Awesome. All right. Let's talk about section 1.7 then. A little bit more about exponential growth and decay. Let's start with problem 4. So if you deposit $10,000 into an account earning interest at 8% annual rate compounded continuously, how much money is in the account after 5 years? So I would just start off by writing down what I want. And I want P when T is equal to 5, or P of 5. And I know my function is going to look like P is equal to P naught, and then either A to the T or P naught E to the KT. Which one do you think I'm going to want to use? With the A or with the E? You can vote in the chat, or just say it out loud.
I'm guessing E to the KT.
Okay, why do you say that?
Because it's a finance question, and that E is always worked into finance questions.
Isn't the 8% a constant? Wouldn't it be like the 0.8?
Yep. That is right. It's good to look for patterns, but in this case, we are going to want to use this one because we're given 8%, and we can relate that very easily to A. What would A equal if it's growing by 8%?
1.08.
Yep. So our equation is going to look like P is equal to P naught times 1.08 to the T. We know that our P naught, it's given to us that P naught is equal to 10,000, and in this case I'm just going to do 10, so the answer is going to be in thousands. Is everybody okay with that? So, and then we have our T, we want when T is equal to 5. So we're going to put this all in. And then we would like push through and find the answer. Again, I don't have my calculator on me. Does anyone have a calculator?
I do. Give me a moment.
Cool.
That's in the box.
Cool. All right, so our answer would be $14,693. And that's how much money you would have in the account after 5 years. All right, so.
Is that right? Oh, I guess so.
It seems right to me. I can check my answers if you'd like me to.
I mean, if they're not letting calculators on the test, they better be okay with just that P equals 10 parentheses, because
Yeah.
I'm not writing down anything.
Yeah, no, they wouldn't make you solve that in like on paper on a test. That would be ridiculous. They would either be okay with this, or they would have you like there would be like some easy way for you to convert it into like terms of E, or I don't know what they would do. But this would not be something you would have to solve in your head on a test. You're fine. I couldn't do that. Okay, do we want to talk about problem 8? Is everybody cool with this? Can I erase
Casey
this?
had a question why it was 10.
Oh, why is it 10? I just did 10 instead of 10,000 because I did it, like, I didn't want to write 10,000 all the way out. So I just said this was in thousands. So if I said this is in thousands, then it's $10,000 or 10,000s. And then my answer was 14.693. And this is like a decimal. And I said this is in thousands, so it would be 14,000. Yeah. All right. Sorry. I shouldn't make shortcuts like that. Okay. All right, let's do problem 8. Find the doubling time of a quantity that is increasing by 7% per year. All right, first of all, are we going to use a to the t or e to the kt?
Let me do an A because this is a growth again.
Yep, and we're given a percentage, and it would just be easier to do that in terms of A. So we want, at the beginning of this problem, I'm just going to like ask myself what this problem is asking for, and it's asking for t. It wants a certain time. I know I'm going to use this equation, and I know that A is equal to, and it's growing, so it looks like this. I know P naught, but what is P if in this question? Yes, sort of. Casey, P is actually 2 P naught. So when we put it in, it's going to be 2 P naught is equal to P naught A to the T. This is the general kind of like if it's doubling, because it's twice what the initial amount is. And then we can cancel out the initial amount, and it doesn't even matter what the initial amount is. Does that make sense? So the way we're going to solve this problem is we're going to say 2 P naught is equal to P naught times 1.07 to the T. And we're solving for T. We have a question in the chat box about going over the quiz problems. There was one problem that Kasha asked me to go over, and we did it at the very beginning. So you can see the recording when we post it. But we're doing like a lot of relevant materials right now. Okay, so divide by P naught. So we have 2 is equal to 1.07 to the T. What would we do to get that T out of the exponent spot? Just take a natural log. So the natural log of 2 is equal to T natural log of 1.07. T is equal to natural log of 2 over natural log of 1.07. We cannot simplify that anymore, so this problem is done. And this is a completely acceptable answer for a time. This is what your answer should look like. This may not, like when you're asked for a time, this may not like look like something that you would really want to respond with, but I promise you this is a-okay. You'll get a lot of questions like this where you'll get natural logs in your answer. Conceptually, with the process of like doubling times and like half-lives, is everybody okay with where they're at there? Could you like rank it? Like, sorry, I do the ranking thing a lot, but I just like want to like be able to know where you guys are. Yeah, we can do a half-life problem. Actually, let's do problem 24. It's kind of a long problem, but it has us taking a lot of information out of a paragraph, which is something that your professors love to do. So I'm going to clear this, and we're going to start 24. Okay. Oops. Okay. So, pregnant women metabolize some drugs at a lower rate than the rest of the population. The half-life of caffeine is about 4 hours for most people. In pregnant women, it is 10 hours. This is important because caffeine, like all psychoactive drugs, crosses the placenta to the fetus. If a pregnant woman and her husband each have a cup of coffee containing 100 milligrams of caffeine at 8 a.m., how much caffeine does each have left in their body by 10 p.m.? Okay. So it's a mouthful of a question. What is the half-life of something? What does half-life refer to?
The time it takes to cut the, there we go, half the initial PO.
Yep. So we're going to start by finding what that time is. Oh, no, it's given to us what that time is. So we're going to start by trying to what? Like, how do I approach this problem? I guess the first question is, am I going to use P naught A to the T or P naught E to the KT?
Because this one's decay, would you do the E to the KT?
It's not necessarily because it's growth versus decay, but here E would just be easier to use because we know that we're going to be taking natural logs at some point in time, and we're not explicitly given a percentage. If I see something like 8% or 20%, even if it's like growth by 8% or decay by 20%, both of these tell me I should use A to the T because I can just change whatever inside here. It will be 0.8 to the T or 0.9 or 1.08 or whatever it is that it's growing or decaying by. But we're not given that in this question, so I would start with E to the KT because I know that I'll be taking natural logs at some point because it's just the nature of these types of problems, and I would like to have them cancel.
Cool.
All right, so E to the KT, I guess like what we should start off with, if you guys aren't going to tell me what else to do, I'll just write down what we have so far. We have, it's a half-life, so I know that my P is equal to 1/2 P naught. And then P naught, E to the K, T. Okay, so I have that equation. It looks like I'm going to have to do this twice. Once for pregnant people and once for not pregnant people. So 1/2 P naught is equal to P naught E to the K, and we're going to say T is in hours. So this is K times 4 hours. And then 1/2 P naught equal to P naught E to the K times 10. And so this is the half-life for pregnant people. And this is the equation for people who are not. What can I do with this? What is my unknown in these equations? Like, what would I end up finding with these equations?
Are we looking for the continuous rate, it looks like?
The whole point of this question, what we want in this question is we want how much caffeine do they have. So we're going to want some p-value at some t that is given to us. In this case, the t-value is 8 a.m. to 12 p.m. would be 4 hours, to another 10 p.m. would be 14 hours. So we want p of 14. That looks like a nice. Does that make sense in terms of like how we're going to solve this problem? Okay. I just want to make sure everybody's on the same page as we continue through this, because this problem is a bit of a doozy. So I know that this is my goal. What if I were to try to start doing this problem right now? I would say p to the 14 is equal to p naught e to the k times 14 what's wrong with this problem? I'm given that p naught is equal to 100 milligrams, so I'm actually going to erase that p naught. And put 100. What's the issue here? The issue is that we have two unknowns. We have an unknown here and an unknown here. If we were to try to solve this problem, we would end up with the natural log of whatever this quantity is equal to, and then it would just get messier and messier from there. We cannot solve the problem from where we're at right now with two unknown quantities. We need to make that one unknown quantity, and the one unknown quantity we need is the p of 14. So that means that we need to use this information to find k. Is k going to be the same for pregnant people and not pregnant people?
No.
Nope. So what we need to do is we need to do this problem twice, one for pregnant people and one for not pregnant people, so that we can compare the end result. So let's start down here. Divide by p naught, just to get it out of the way. 1/2 is equal to e to the 10k. And this is why I picked e, because I'm going to take a natural log. So the natural log of 1/2 is equal to 10k times the natural log of e, which is equal to 1. The natural log of 1/2 is actually natural log of 1 minus natural log of 2, based upon our rules of natural logs, correct? And what is the natural log of 1? 0. So this is just the negative natural log of 2 as well, is equal to 10k. And then we divide by 10, so k in this instance is negative natural log 2 over 10. And a lot of the times when you are finding k's, they're going to have some form of natural log in them. Okay.
When you get to the end of the page, like, oh, never mind, my screen wasn't going away.
Oh, sorry. Okay, so we have 1k. There we go. What do we do with this? Well, we're going to say we're still looking for p of 14, but now we have one of the missing pieces. We can say this is 100 e to the k times 14, which is our t. And just to simplify what's going on up here, that is like that. And so this is all in an exponent. Sorry. and you get fractions up there that can look a little funky. Does anyone with a calculator want to put that through?
I don't get how you got that -7 divided by 5 with that 14.
Oh.
Like, how does that work?
What I did is okay, so this here is negative natural log of 2 over 10, and I just did times 14. So I said negative 14 natural log of 2 over 10, and then I divided, or I like multiplied both sides by 1/2. So I did like times 1/2 times 1/2. So this is -7 natural log 2, and this is 5. And I just did that to simplify it down.
Okay, gotcha.
Because, yeah.
Thank you.
Yep, no problem. All right, so we have 37.89. Okay. There is our first part of the problem that we needed to solve. All right. Oh my goodness. What the heck? Sorry, my phone has like a voice activation thing that it cannot control. Okay. Let's do the next one then. Same sort of process. We divide both by p0. 1/2 is equal to p0 e to the 4k, or excuse me, just e to the 4k. Oops. It's gone. Take the natural log of both sides. So natural log of 1/2 is equal to 4k natural log of e. That's equal to 1. This we know is equal to the natural log, negative natural log of 2. We did that down here. 4k. So k is equal to negative ln2 over 4. Cool. Now that we have k, we're just going to do the exact same thing. We're going to say p of 14, because we still want p of 14. We want it like what happens at 14 hours is equal to 100 milligrams times e to the negative natural log of 2 over 4. Yes, give me just 1 second. I'll finish writing this out. Times 14. And we're going to do the same sort of simplification thing where we, or at least I like to do that before I start putting things into a calculator. So it's 14 natural log of 2 over 4 is equal to 100 e to the negative 7 ln2 over 2. Okay. If somebody would like to put this into a calculator to find what p of 14 is, while I explain how I got this. Okay. All right. So we know in our logarithm rules that the natural log of a minus the natural log of b is equal to the natural log of a over b, right? So we're going to consider this as this. We're going to say that we can write it in this form, or the natural log of 1 minus the natural log of 2. And the natural log of 1 is actually equal to 0. Because, oops. Okay. Thank you. We got an answer for this. So P of 14 is equal to 8.84. Back to this. Natural log of 1 is equal to 0, then this whole thing is actually just equal to 0 minus natural log 2, or minus natural log 2. Is everybody okay with that? Relating these two? Cool. All right, so now we have the information we need. Actually, we have our answer. We were asked to find how much caffeine is in their bodies at 10 p.m. The answer for the pregnant person is 37.89 milligrams, and the answer for the not pregnant person is 8.84 milligrams, which is a pretty big difference. Okay, that's it. That's the whole problem. What are your guys' thoughts on how this problem was solved?
I just want to make sure I'm getting 100. I get it.
Yes.
The 14 that you got, that is from the 8 a.m. to the 10 p.m., correct?
Yes, it is.
Okay.
So I just went, 8 a.m. to 12 is 4 hours, and then 10 p.m., 12 to 10 p.m. is 10 hours, and so I just did 14 hours.
Okay, I wanted to make sure I'm.
Yep, absolutely. Feel free to ask all of the questions you need. This is about making sure that you guys can look at a problem like this on a quiz or an exam and say, hey, I know how to do that. And it really is very much, most of the problems you'll encounter this semester are just breaking it down. What does this problem actually want from me? How do I get that with the information that I have? Which is one of the reasons I always start off by, this is something my calculus professor did a lot, is like asked us to like define what exactly it is that we need. What do we want from this problem? What are we given? How do we get there? Okay. Are you guys feeling a little bit more comfortable with exponential growth and decay kind of functions? Awesome. All right. How are you guys feeling about section 1.8? All right, we have one vote for 10. Anybody else?
I'll be working on that today, so I haven't really got
Okay. All right, we have another vote for 10. Section 1.8, we can do maybe, I guess if everybody's feeling good about it, then we probably wouldn't have to do a problem from here. But it is basically just like relating things. And you guys aren't doing any stretching, are you? Like stretching and compressing graphs? Maybe, maybe not. I don't think so. Okay. What about section 1.9? How do you guys feel about 1.9? Scale of 1 to 10. I'm getting no votes. Not at all. Okay. All right. Yes, I can do an example. No, that's okay. Don't be sorry.
I went to the restroom real quick. I could hear you, but I couldn't yell back. Could we do an example from 1.8 before we move on?
1.8? Yeah, for sure. Okay, I am going to erase this problem if everybody is okay with that. No objections, so there it goes. Okay. So 1.8, we're currently on page 63. Let's do problem 4. We are given two functions. F of x is equal to x squared, and g of x is equal to 3x minus 1. Okay. Later on the semester, you're going to be doing a lot of stuff with functions that kind of look like this and relating them to one another. So this is like not, this is actually like an important section to kind of like recall as you continue on. And when we get to that point in the semester, I will tell you that I literally write it out every single time. What is f of x? What is g of x? How do I relate the two? This problem, we're asked to find f of 2 plus g of 2. So, just to start off with, what is f of 2?
Doesn't
Yep, 4. And g of 2 is going to be 3 times 2 minus 1, which is 5. So these are just putting in whatever x is into the function and seeing what it spits out. And then we're going to say, what is f of 2 plus g of 2? Well, that is 4 plus 5. So the answer to A is 9. Did everybody follow how that happened?
Why'd you do the 4 plus 5?
Okay. It asked for f of 2 plus g of 2.
Oh. Okay.
And so my problem, I found f of 2, I found g of 2, and then I put them where they needed to be.
Gotcha. That makes sense.
So, B, we're going to do f of 2 times g of 2. So we know f of 2 is equal to 4, and we know that g of 2 is equal to 5 from our work over here. So this is equal to 20.
Okay.
Cool. Okay. Now we're going to do C, which looks like this. F of g of 2. And this notation basically says we're going to start by finding what's ever on the inside, and then we're going to find what number that is, and we're going to put that number into F. So we're going to start by finding g of 2, which we already found. G of 2 is equal to 5. And then we're going to take this number and we're going to put it back in here. So if g of 2 is equal to 5, then we need f of 5. Does that make sense?
Yes.
Okay.
So
f
then
of
f of 5 equals 5 squared?
Mm-hmm.
25?
Yep. And that's the answer to C. All right. Last but not least, we have D.
Which is just reverse. You would find it would be 4, and then you would plug the 4 into the G problem.
Exactly.
G 4 equals 3, 4 minus 1.
Yep.
I was talking out loud. I hadn't actually solved it yet.
Exactly.
Cool. Oh yeah, this is a 10.
Okay.
Good.
Are you guys doing graphing from this section? Because I thought you weren't, but Casey's asking us to do a graphing problem.
And there have been graphing situations on the exam on these, and like the next page, page 64, it's all graphs.
Yeah. I, for some reason, thought you were not doing any stretching or compressions, but maybe my information was wrong. I will definitely talk to Kasha about that. Let's take a look. What kind of graphing problems do you want to give a try? Like maybe like 20? Like, are you looking, okay, yeah, are you looking for stuff like 20, or are you looking for stuff like 42 or 44?
I mean, both look pretty confusing.
Yeah, I think that 44 is not something that you're covering. And if you are covering that, I will eat my words and I will teach you next week. But I'm pretty sure that you're looking for mostly stuff like 20. And that's essentially exactly what we just did, but we have a graph that like orchestrates it all.
Yeah,
so
it's been more like, is this concave? Is it going up? It's asking more of what does the graph look like versus.
Okay.
Does that make sense?
Yeah. Okay, yeah, we can talk about that for sure. To start with, though, let's try number 20. 20, well, we're going to do 20, 22, and 24. So 20 is asking for f of g of 1. 22 is asking for f of g of 4. And 24 is asking for f of 2. So this kind of just makes you harken back to what is a function. Because we're given stuff like g of x is equal to, in the last problem, it was 3x minus 1. But if we were to graph this, this would be a line on a graph. So basically, what we are instructed to do in this problem is find the point on a line. If we're given an x value, if we're given x is equal to 1, what is y equal to? And that's what our g of x is. Are people comfortable with that as like a concept?
And so like for 20, we would have to find the inside first, so you look for the g of x graph first. No?
Yes, exactly.
And then
so,
be 1 on the x-axis and then
yep,
2 on the y-axis. So that it would
exactly. So here, let me erase this. Given by our graph, g of 1 is equal to 2, as you just said. And so now we have to take this and we put it back into this. And so now we're looking for f of 2. And we do the exact same thing on the f graph.
4.
Yep. And that's our answer.
These problems are like aesthetically scary. They look very.
I know. That's very true. But you just need to kind of relate what you know about like what a function is to what is given to you. Okay, let's try 22. What is g of 4?
1. No, g of 4 is 5.
Mm-hmm. So we need to find f of 5.
And that is 1.
Yep. Okay, what about this last one? What did we start with?
F of 2
is 4.
Is 4, and then f of 4
2.
2.
There it is. That's literally all you need to do here.
Sweet.
So don't panic. It'll be fine. Do you want to try something that's like not like a line? We could do 26.
Sure.
Okay. So here we need f of g of 1. G of 1 is what we're going to start with.
Okay. 0. 2?
Yeah, I'll say that's about 2-ish. Yeah, that is 2. That is 2. Yeah, let's call it 2. All right, so f of 2 then.
Someone was drunk when they did these lines.
That looks more like 0.4.
Yeah, that works.
Yeah.
All hard and up.
You're just making estimates here. So, yeah, let's do 0.4. That looks good to me. You guys know how to do this now. So, theoretically. Okay. Goodbye, Paul. I'll see you next week. Okay. Everybody cool with what we've got?
Yes.
Everybody cool with 1.8? Cool. All right. 1.9, proportionality and power functions. Rank yourself 1 to 10, comfortable with this information. In reading through this, there's a lot of like word problems, but it's just kind of like comparing things, I think. All right, let's do problem 4 from 1.9. We are given y is equal to 3 over x squared. Is this a power function? Keeping in mind they told us that a power function looks like this. So x squared would be a power function. X to whatever this number is would be a power function.
But isn't it because it's in the denominator it's not?
Well, is it in the denominator?
Or
Can we make it not be in the denominator?
Yes.
We can. What would it look like if that x squared was not in the denominator?
3x minus 2.
Yep. Exactly like that. So you can switch exponents from the denominator to the numerator by making them negative. This is going to come in very handy later as just like a tool. So please get comfortable moving things from the denominator to the numerator. But if it's written like this, is this a power function? -2 is a constant number, so it is.
yes.
All right. What about number 9? That looks like y is equal to 3 times 5 to the x.
No, because x is in the exponent spot.
Exactly. So, and then let's just think very briefly about question 14. We're given energy expended by a swimming dolphin is proportional. When I do this, I kind of like note down things in terms of like math and variables as I'm reading the problem. So I know that energy is proportional, and this like alpha thing is what I use to say proportional. But you can use whatever notation makes you feel comfortable. So when I see this, I think is proportional to the cube of speed v. So speed is cubed. And I'm supposed to write a formula that represents this. So E depends on V, so it's E of V equals some constant times V cubed. And whatever this constant is, it'll just affect the final number. But I know that E is reliant on V cubed. Are people comfortable with how I did that? This whole proportionality thing, they just kind of want you to think about how things are related. So all this is saying is that if V cubed goes up, then E is going to go up. And the amount that E goes up depends upon K. So if it were just E is equal to KV, and V were to go up by 1, then E would go up by K. Make sense?
If we have a problem like the one we did before, like number 9, and let's say instead of an X, the exponent was like a fraction or a decimal, is that still considered a constant number? Because
it's a good question. If we're gonna call this 9.5, if it looks like this,
yeah,
what I could do is I could just solve this. This is equal to a number.
gotcha.
So it's not even a function. We would just end up with y is equaling some number. In this case, it would be, again, something that you can get comfortable with is this 1/2. If something's to the 1/2, it means it's the square root of something. So 5 to the half is equal to the square root of 5. So this, whatever I put this into my calculator to be, would be whatever y is.
Okay.
Okay. We have a request to do 15. So let's do that real fast. The average velocity v for a trip over a fixed distance d. So v over d is inversely proportional to the time of travel t. So I do it like this. And d belongs here because both velocity and distance are going to affect how long the trip takes. So that's how I would start by setting it up. And the way that I do that is to just check to make sure it makes logical sense. If I went slower, it would take more time. And this, what I do with this little thing is I just reverse the direction of the arrows. This I use to mean inversely proportional. So if I go slower, it'll take more time. Okay, let's think of it in terms of distance. If the distance is, if the distance goes up, if the distance is longer, it says it'll take less time. So something's not right with the way that I have this set up. What if it looks like this? This way, if the speed goes down, or if the speed increases, speed goes up, time goes down. All right, so that kind of makes sense, logically speaking. Okay. What about distance? If distance increases now, that'll make this whole thing smaller, which, if I think about it in terms of an inverse, will make time bigger. Are we cool? So it's going to look something like t is equal to some constants, and then v and d. The thing that makes this problem complicated is, one, it's got 2 variables. We have 2 things to worry about here. So this is actually a function t of v and d, which you don't have to worry about in this class. It's just asking you to think about how you can relate a change in one to a change in the other. And usually they'll do it in a way that you can check to make sure it makes logical sense. Cool. All right. All right, 1.10. How does everybody feel about periodic functions? Okay, we got a 4, we got an 8. This is something that, like, traditionally, I think some people struggle with because they don't have a lot of exposure to, like it's been a while since you guys have had trig. It's been a while since I've had trig. It is tough to explain to you the whole point of, like, a periodic function like this. But so what I would recommend to you, and usually I'll tell you, like, you should understand as much as you can because that'll mean that you are better at problem solving. But for periodic functions, it matters, like, what these look like matter so little in the grand scheme of things in terms of this class. I would just recommend that you brute force memorize the amplitude rules, the period rules, and the vertical shift rules. So vertical shift is C, period is equal to 2 pi over B, and amplitude is equal to the square root of A when a function looks like this. Or last year I tried to, like, explain, like, exactly, like, why a trig function worked, and I think it confused people more than it helped. So I don't think I'm going to do that again. But what I would recommend you do is just, like, connect amplitude to this location, period to this location, and vertical shift to this location after the fact. Vertical shift is not, like, multiplied or like a part of the periodic function. That being said, another thing that I would recommend you guys, like, just, like, committing to memory is, like, what these kind of look like. That is the general shape of a cosine wave. So if you see something that kind of looks like this, where it starts and ends at about the same y value, think cosine. And this is one period of the cosine wave, whereas this is going to be a sine wave. And you see how I could just keep repeating? I could take another, like, copy of this and put it next there. Okay. So those are, like, the basic things that I think you should know regarding what's going on in this section. We can do a couple problems with that. But this is basically what you need from this section. Okay, so let's do problem 2. All right, what is my amplitude? Amplitude is going to be this number right out in front. So it's just going to be 4.
Oh, 4?
Yep.
I didn't realize that was muted, sorry.
No, you're good. Okay, so we have that. Now how do we find the period? This 2 here is B, and we know that period is equal to 2 pi over B. So it's 2 pi over 2, which is equal to pi. So our period here is just going to be pi. What's our vertical shift?
X.
This is actually one term. It's the cosine of 2x. So our vertical shift is 0 because there's nothing out here.
Ah, gotcha.
Yep. Another thing is that people have a tendency, me especially, this is something that I probably shouldn't do as much as I do. People will write things like this. And what it means is the sine of 4x. This on its own doesn't mean anything. This is a number. This is like a function that like doesn't have any variables in it. If I write it like this, what I mean is that this is 4 times x, and this makes it a function that actually like changes. Because if it's just sine of 4, it's just a point. There is one specific number that this correlates to. Okay. Okay. We have a question about simplifying for the period. Specifically, if you have 2 pi over 1/2, how does that equal 4 pi? This is something that I guess the guy who taught me how to do this just called it jumping the fence. When you have a fraction in the denominator, take whatever's in the denominator of the denominator and move it to the numerator. So 2 pi over 1 times 2 is how I think of it. The technical like thing that's happening here, yeah. The technical thing that's happening here is you're going to be multiplying each side by 2, or multiplying the numerator by 2 and multiplying the denominator by 2. And so when you multiply 1/2 by 2, it's equal to 1. And when you multiply 2 pi by 2, it's equal to 4 pi. So whatever helps you think about it. I usually just like move it up there, but if you want to multiply it all out, you can definitely do that. Okay. Let's take a look at 12. No, yeah, let's take a look at 12. We're finding a formula, so what we want here we want to make ourselves a function. So I would start by saying, what am I missing from my function? I have h of x is equal to a, and this looks to me like it's upside down, but it looks like a cosine. So I'm just going to say negative a cos b x plus c. Okay, and the reason I put this negative sign here is because the graph of a cosine normally looks like that, and this one looks like this. So it's just upside down. Okay, so I need A, B, and C from this graph. I'm going to find A by finding out what the amplitude is. I know my lowest point is -6, and my highest point is 26, and the difference between them is going to be 32. So if I'm looking at this graph, this distance, it's actually probably something that looks a little bit more like that. Sorry, my graphs are kind of sloppy. This distance is 32. Okay, so, all right, what then, this will actually help me find C as well. My amplitude is going to be half of that because my amplitude only goes from like the middle up. Like if it's a sine wave, this is my amplitude. So, and this. And if it's a cos wave, this is going to be my amplitude. And this is going to be like my negative like portion of it. So my amplitude is going to be half of this. So my amplitude is equal to 16. If my amplitude is equal to 16, and my lowest point is at -6, then consider a graph that is actually with no vertical shift of an amplitude of 16. How much am I going to have to move it up to have this low point be at -6? I'm going to move it up by 10. So my amplitude is still 16, but it's been moved up 10 because this low point is not at -16. So we have h of x is equal to -16 cosine. We still haven't found b, but we have found c. All right, b. Period is the amount of time it takes for a wave to do one cycle. This is, for a sine wave, this would be one cycle. For a cosine wave, this is one cycle. So what is the time from the beginning of the cycle to the end of the cycle? The wave begins at time equals 0 and ends at time equals 12. And theoretically, it will just keep repeating and be like on the same cycle every 12 months. So if we use our equation that we're given, 2 pi over b, what we're trying to find is b. I would multiply both sides by b. 12b is equal to 2 pi divided by 12. B is equal to 2 over 12 pi, or B is equal to pi over 6. So when push comes to shove, we have this formula, h of x is equal to -16 cos pi over 6x plus 10. Which is just a lot in a very short period of time to gain from one graph, I think. Like when you're like just looking at it and trying to like figure out what equation is associated with this graph. And I promise this section is the only time that you're really going to be looking at a graph and finding an equation off of it. I don't remember doing this at any other time, just this section. So if you make it through this, be familiar with what these graphs look like. Be familiar with what an amplitude is, what a period is, what a vertical shift is going to do to a graph, but don't worry about this being integral to the rest of the semester. How are you doing? Cool. I think we're going to call it quits for now. Usually these shindigs last about an hour. This went a little long. That's okay. All right.
Thank you.
No more questions. I will talk to you all next week. Have a good day and have a good week.